All right, so the next thing I want to do is give you some real-life examples of linear functions, of their graphs, and how things can be interpreted and understood. The figure below gives the median age in the United States since 1850. Median is the age in the middle, so it kind of shows you here that since 1850, the median age, for the most part, has been going up. If we approximate this graph with a straight line, what is its equation relative to year 1850? And then it says use this particular graph. So the first thing I need to do is actually draw that straight line. And then I need to take what I know about y equals mx plus b to write the equation of that line. And when it comes to y equals mx plus b, there's basically two things that I'm looking for. I'm looking for the slope and I'm looking for the y-intercept. Now, it's really easy to find the y-intercept because it's where it touches the y-axis. It's right here. It's slightly below 20. I went with 19. If you wanted to make an argument for 18, feel free. When I give an answer to something like this, I will not put one answer like plus 19 and the other answer plus 18 with more or less the same slope, because you could be argued either way. Okay, so there will be a clear and obvious answer in terms of what the correct y-intercept is. Now I got to figure out the slope though. And to figure out the slope, I need 2 points on this line. So the first point I'm going to use is this point right here where we began, 0, 19, the y-intercept. The next point I'm going to use is going to be up near the other end of the spectrum. That'll be at the year 2050, which is the end of the graph. And I'm estimating here, I'm not exactly sure, but I am estimating that that value where at 2050 is about 38, okay? So the mean age in the year 2050 is estimated to become 38. So now let's take a look and see what we get. To find the slope, I'm going to do change in y over change in x, which is 38 minus 19 over 2050 minus 0, which is 19 over 2050. So what would then be the correct equation of the line? Y equals 19 over 2050x plus 19. Okay, so that's our equation of a line. Just by looking at a graph of data, we can come up with an equation of a line, so that if I was to plug in the year and do the calculation based on that, I would be able to find out what the value is, okay? I would also say that you're going to use the years since 1850 to do this, okay? All right, let's take a look at the next example that we have. Near and dear to my heart, given the fact that my life is very involved with dogs. What's the equation of a line representing the maximum dosage for dogs? This is actually kind of a big deal because sometimes with some medications, particularly the puppy ones, when they are first getting their inoculations, things like parvo and distemper and so on, they just give every dog the same dosage. And that's kind of crazy because of the weight differences. But it's really, really important as they get bigger. I mean, dealing with a Rottweiler in this diagram who is pushing 200 pounds, and his dosage is going to be a little bit different than a standard poodle. Okay, so what is an equation? Well, you do the same thing. And I would just say that in order for us to really know, let's all use the same point. Can you see up here? I put an arrow in, all right? And that would be approximately 200 comma 150 or so, all right? So go ahead, write the equation of the line representing the maximum, the red, dosage. Go ahead. Okay, in the stop and start realm, the y-intercept is 60 because the red line, well, it's a yellow line, but it's highlighted with red little streaks here, is 60. And as far as the slope goes, I'm going to use 0, 60, and I'm going to use 200 comma 140. I guess I thought that was closer to 140. And again, if you used 150 and all your work is correct, then you would be given credit for the work. The slope is going to be y sub 2 minus y sub 1, or change in y, and that is 140 minus the 60 over the x, which is 200 minus 0. So that gives me 80 over 200, which reduces to 2/5. What's the correct equation? Well, now that I know the slope, okay, and now that I know the y-intercept, I am in. Y equals 2/5 x plus 60. And there is your correct answer. Okay, so some more real life applications. I got one more for you. This one we're going to go differently. This time they tell you when it's talking about the linear function example in real life of a plane taking off, and that kind of looks like a plane taking off, that the correct equation is y equals 55x plus 20. I want you to prove that that's the correct equation. There's more than one way to do this. We have not done anything like this yet. So give it a shot, and we'll go over and see if you chose one of the two ways that I present to you. Go ahead. Using stop and start, of course. All right, so one way to do this is to just derive the equation, to do it exactly the way we just did with the dogs and with, what else did we do? Oh, the median age problem and so on and so forth. So to do that, I need the slope and the y-intercept. So the y-intercept is 20. I know that's 20 because it says 0, 20, and the y-intercept always pairs with 0. And then I need y equals mx plus b. I also need the slope. And I just used the first 2 points here, and I did 75 minus 20 over 1 minus 0. So that gives me 55 over 1, which is 55. And yes, plugging in a 55 for the slope and a 20 for the y-intercept, I get y equals 55x plus 20. Correct answer. Nicely done. All right. Next up. How else could I have done it? Well, I could have checked and seen if 2 points, you have to do at least 2, you could do more than 2 if you want, are all on the line. And plugging in the coordinates, when x is 1, y is 75, that checks. And when x is 3, y is 185, that checks. So if I check that the points on the line do check, then that means that that's the correct equation of the line, because if those points did not check, then the equation would be wrong. All right, so there's 3 real-life applications where linear functions are involved. In fact, you know what I'd like to do? I'd like to take a step back and think of what a function is again. A function involves input and output, okay? We can express a function in many different ways. We can give it a rule, like f of x is 2x plus 1. There's a linear one. Or y equals 2x plus 1. Remember, f of x and y are the same exact thing. I can express it using a table. And when we first started graphing, that's how we did our graphs. We used a table. I can express it as a picture where I show the domain and the range. Remember that the domain is the set of all the inputs. The range is the set of all the outputs. Or I can express a function as a graph. Those are all normal, acceptable ways to express a function. Now, something else that's important to remember, or some terms it's important to remember, the domain is set of all inputs. They are the x values because x represents input. The range is the set of all the outputs, and that's the y values. And you can see that here where it says domain and range and the diagrams of the blue egg shape and the green egg shape. And you can see the arrow shows the sense that 2 is becoming 4, 1 is becoming 1, and so on. So that's a picture of input-output. That's how we write the coordinate pair. And since x represents input and y represents output, we write xy. But we understand that what we're really talking about is input and output. Now, how do I talk about different types of functions? Well, that I'm going to do next.